email, why don't you send me an email just letting me know so I can just send it to yours specifically, just in case for some reason I don't have your email in with everybody else's. Okay. Alrighty, so here's what we're gonna do. There's only a few slides. We're just gonna cover 2.2 today. So the basics of what we're gonna do is associated with taking information, which we call data, and matching it to an equation. So let me kind of give you an overview of what I'm really trying to say. In the past, did you have to create some equations? Yes. And did you use y minus y1 equal m times x minus x1 to create those equations? Yes. Okay, now we're getting into a section of this particular class where we have a tool that will create that equation for you. Isn't that a wonderful thing? So I'll show you how to do that today. So you're going to be given data. And data, anytime you hear me use the word data, I mean XY table. XY table is just data, and it's data about any particular topic we could be talking about. So we're going to talk about the specifics of having an exact model, which is an exact equation or an approximate equation, the fitting the lines to the data, and discrete and continuous functions, and how to apply this to real life. So here is the first slide. So let's talk about some data. First slide.
Excuse me.
I skip one?
No, are you recording this?
Yes.
Oh, okay.
Yes,
That's
yes.
okay.
Okay, good. No, we're recording. Yeah, we're recording. Alrighty, so on this first slide, we have some data. Now, can you see the data table? Okay, what's the X values? Months, month 1, 2, 3, 4, and 5. Do you agree? What's my Y values? The totals, which is 107, 129, 151, 173, and 195. All right, those are my totals. So my X and my Y's I have, that's just data. It's just the XY table with data. It's a horizontal table as opposed to a vertical table, but it's still XY data. Questions, what you see in the table. Do you have any questions about the XY table, first of all? Okay, now we want to do something called first differences. In order to find the first differences, you have to take these two numbers, where's my cursor? These two numbers and subtract them. You see those two numbers? If you subtract them, what you get? 22. If you subtract these two numbers, what do you get? 22. If you subtract these two numbers, what do you get? And these last two numbers you subtract, you get 22. So all we just did something we call the first difference. Doesn't the word difference mean subtract in math? If I say what's the difference between these two numbers, aren't you going to subtract? So it's saying what's the first difference, meaning you're just going to give me the differences between each set of your Y values. So you understand how they got the number 22? Yes? Okay. So with that said, if all of your first differences is constant, meaning are they the same? Are they?
Yes.
If they're all the same, then there is a linear function or linear equation that matches that data. You understand what I'm saying? There's a linear equation that matches that data. So let me give you an example of one that we already did a few weeks back. Some data that we've used that you've seen before. All right, here is my XY table. Tell me if this looks familiar to you. That's not supposed to be it. Damn, this looks familiar. I'm putting up here 1, 10, 2, 20, 3, 30, and 4, 40. Does that table look familiar to you? Is there an equation that matches that data? Well, if I plug in a 1, how do I get a 10 out? If I plug in a 2, how do I get a 20 out? If I plug in a 3, how do I get 30? What do we have to do? Multiply by 10. So the equation that matches this data is that. It's y equals 10 times x. You agree? Yes. That equation, if I plug in a 1, I'm going to get a 10. If I plug in a 2, I'm going to get a 20. If I plug in a 3, I'm going to get a 30. So that's the equation that matches this data. You okay with that? Mm-hmm. Our goal is to create an equation that matches or comes as close as possible to the data that you're going to be given. So you have data, and they want to know, is there an equation that's an exact match to the data? And when is it an exact match? When all the first differences are the same. When all the first differences are the same, then you can say there is an equation that's an exact match to the data. All right, so here we go. Next one. Look at the next one. Did they do the first differences again? Yes, they did. They changed some of the Y data. The Y information got changed. So now look at my first differences. I got a 22, a 24, a 21, and a 21. Are those numbers constant? Meaning, are they the same?
No.
They're not. Are they kind of close? Yes, 21, 22, 24, they're kind of close to each other. So, is there a linear function or equation that can be modeled to fit that data? Approximately. So, that's the question they're going to ask you in the homework. Is there an equation or function that will model that data exactly, approximately, or not at all? If the first differences are kind of close, you can say approximately. If all the first differences are the same, you say exactly. We okay? All right, your turn. What we gonna do? Okay, so we gotta find the first differences. What's the difference between 4 and 7? The difference between 7 and 10? Between 10 and 13? And between 13 and 16? All these first differences are exactly the same. They're constant, which means, is there an equation that models that data exactly, approximately, or not at all? Exactly. The good thing is that we're going to tell you where to put this data, so it'll create the equation for you, and you ain't got to do the y minus y1 equal m2. You ain't got to do none of that on this slide. Ready? Okay, so you just told me it was an equation that models it exactly. What about the next slide? Look at the next slide. I've got 7, 14, 20, 28, 36, and 43. All righty. Tell me what the first difference is for the first two numbers.
7.
Okay, that's 7, 14. The difference is 7. What about 14 and 20? 6. Is it 6?
No, hold on.
Just checking. Y'all check my math. Is it 6?
It's 6.
Okay, between 20 and 28.
8.
Okay, and between 28 and 36? 8, okay, and between 36 and 43.
7.
Okay, now based upon the data table that you see, the XY table, is there an equation that models it exactly, approximately, or not at all?
Approximately.
Why? Because 7, 6, and 8 are all pretty kind of close to each other, aren't they? So that's what we say. We would say there is an equation that will model or fit that data approximately. All right, here's the next slide for you to try. All righty. 2, 5, 10, 5, and 2. Does it matter that these numbers go up and down? Nope, that don't have nothing to do with it. What's the difference between 2 and 5? 3. The difference between 2 and 5 is 3. What about 5 and 10? And then 10 and 5 again? And then 5 and 2? Approximately? Exactly, approximately, or not at all? Approximately. These numbers are still pretty close together. Now let me ask you a question. When is it not at all? When is the answer, well, none of this data? Well, let me give you a data table to see. So, I'm looking for my eraser. So here is one that you can see for yourself. Give me, I didn't put it back in here. All right, we'll use something else. All righty, here we go. Here's my data table. 1, 2, 3, 4, 5, and my numbers. 10, 60, 300, 1,000, and over here it goes with that number. I made them too big. All right, over here, this number is going to be 9,000. All righty. The differences, here are my X values, here are my Y values. This is my data table. So y'all can see my numbers kind of got squished. All right. The difference between 10 and 60, how much? 50. The difference between 60 and 300? 240. The difference between 300 and 1,000? 700. And the difference between 1,000 and 9,000? All right. Is there an equation that will model this data? Exactly, approximately, or not at all?
Not at all.
Not at all. Those numbers ain't nowhere close to each other. So the answer is not at all. Well, let's look at it from a graph standpoint. Okay, here's my graph. I'm graphing data. Can I graph this on a graph, or can I plot these points?
Yes.
Can I plot these points?
Yes.
Okay, and so when you plot the points, the graph could look like this. Here's one graph. Here's my x-axis, my y-axis. Here's my my one. Alrighty, that's data that I plotted. Does it look like it's a straight line, kind of, sort of?
Yeah.
Okay, so if it looks like it's a kind of, sort of straight line, is it straight? Like, is it a perfectly straight set of dots?
No.
No. So, but can I draw a line that comes as close to these dots as possible?
Yeah.
Yes. Okay, that's called the best fit line. It's the line that's the best fit for that data. Now, is that line exactly an exact fit, an approximate fit, or not at all? It's an approximate fit because guess what? It doesn't touch every single point. If the line doesn't, you can't curve the line, you can't draw it like you connecting dots. You got to draw one straight line. If that straight line touches every single dot, it's an exact match. If it touches almost all of them, it's an approximate match. So let's do one. So this one was approximate, right? All right, there's an approximate match of an equation. So the approximate, here's another one. Look at this data. I'm drawing here an XY axis, and here are my points.
Not at all.
So even if you try to draw a line, it ain't gonna touch none of those points at all. So this is when you would have the situation like what I drew in this last table. All these points, these dots are all over the place, so you're not gonna have an exact match, an equation that's a match, not at all. No equation to match this data. Okay? And then of course, if you got one that's an exact match, here's what the exact match looks like. So there you go. So I have data with an exact match. There's an equation that's an exact match. Okay? So the difference between what you have on the screen here is that's just a data table with an XY table. Here's an actual graph that shows you I plotted the data from the table, from the XY table, and this is what it looked like. So if you're not sure if it's a good match, can you just plot the points and see if it looked like you could draw a straight line through it? Sure, you could. So then you can see if it looks like it's approximately or not at all. Now again, what if your points look like this? What if your points were these here? And what if my points look like this? It's still approximate. Can you draw a line that's coming straight through these points, even if it doesn't touch them? Yeah. So here's my line. Whoops, it's supposed to be a straight line. It ain't supposed to curve at all, y'all. It's supposed to be a straight line. Now, does it touch every point? No. Does it come close to them? Yes. So this is an approximate. There is an equation that's an approximate match to the data. So why do we do all of that? Because the next slide says we're looking for the best line that's going to fit the data, because we call it a best fit line. So over here, this is the best blue line I see. That's the best line I can get that's going to match this data. Here, this is the best fit line that's going to match this data. Here, this is the best fit line that's going to match this data. There is no best fit line to match that data. There is not one. Okay? So just when you see that word best fit, they just want to know the line that's going to come the closest to all the points as possible. Okay? That line is called linear regression. So you see the definition at the top of the screen. It's called linear regression. And that's the tool that we're going to use, or at least that's what's in the tool that we're going to use that's going to actually create the equation for us. Okay? So next slide. You have some data. I need you to go to Desmos for me, please. It says construct a scatter plot of the data in the table. Go to Desmos, type those points in. Do you know how to do the data table again? Go when you get into Desmos, look at your top left, there's a plus sign. Click on the plus, and it'll open it up so you can start typing those points in. Go ahead and type them in for me, please. Go to Desmos, desmos.com, and type those points in. Did everybody get the sign-in sheet?
No.
Where's the sign-in sheet at? Who got it? Oh, it's up here. It's up here. I got it. Who needs it? Okay, so just pass it back around, guys. Let me know once y'all got them typed in. If you can't see any points, what's wrong? Your window got to be bigger. How big should your window be for the x-axis? How big should the window be for the x? At least as big as 16. I would make it 20. How large should your y-axis be? At least 27, but I would make it 30. You can zoom in and zoom out till you see all 7 dots. If you can't see your 7 dots, your window not big enough. You got it? Y'all got them plotted? Okay, you got it. Can you see them? If you can see them, let's look at bullet number 2. It says determine if the points that you plotted appear to be near some sort of straight line. Does yours look like they're kind of sort of in a straight line? Because if they do, then that means what? Are they all on the same line, or they look like they almost all on the same line? Almost. So what's that going to be? Exactly, approximately, or not at all? Approximately, there's an equation that matches. It's the best fit for that data. Approximately. All righty. So look at bullet number 3. What does bullet number 3 want us to do? Create the equation. And guess what? You don't have to do y minus y1 equal m times x. We're going to go jump to another tool so you can figure out how to do this with the tool, that you don't have to do it by hand yourself. The name of this, go to this particular website, so don't close your Desmos, leave it open up another window. Here's the window. www.zuru.org. That's the website I need you to go to. Make it a favorites. Okay, once you've made it a favorites, we're going to go to that site so you can type it in. So let me find mine. Here it is. Here's my site. Let me scoot this over so you can see it. Let me minimize that one. All righty. So you can see that I got my numbers typed in here. Do you see my numbers in Desmos already? Over here is the screen that you just pulled up. So when you get to that screen, let me go back to the home button for a second. All right, this is what you should have. Did you get that? Was this your original screen?
Yes.
Okay, click on regression tools off to the left. It says regression tools. Click regression tools off to the left, and this is the screen that you should be on. Now, you will use all of the first 1, 2, 3, 4, 5 bullets. And you can look at them from the top or the side. So here is linear, logarithmic, exponential power, and polynomial. We'll do, here they are right here. Linear, logarithmic, exponential power, and polynomial. The first one we're going to do is the linear one. So click linear regression. And like I said, make that screen the favorite. We are doing linear regressions. We're creating lines, linear equations. Guess what I want you to do with that data? I want you to type it in here. Now you're going to type it with commas like you would 1, 2, 3, 6. So just like you see Desmos, type those in right here. So 2, 5 is going to be your first point that you're going to type in the yellow box. You see your yellow box? Type 2, 5. Enter. It'll drop down to the next line. Type 5, 10. We're just typing what you just put in Desmos. 8, 14. 9, 16. 10, 18. 12, 21. And 16, 27. You cannot put X comma Y in here. It doesn't like words and letters and all of that. Just numbers. You can put a comma or a space. So I could put 2 tab 5, 5 tab 10. You can put a tab between them or a comma between them. And you can't have multiple commas. So if your number was 20,000, you can't put 20,000 with a comma. It can only have one comma. The comma that you see, the X and the Y can have a comma between it. That's it. No other commas. No exclamation marks, no other symbols, just numbers and commas or a number and a space. After you got them all typed in, hit the word calculate. And where your word results, you see where it says results? That's your equation of that data. That is the equation that models the data that's in Desmos that you see. What we're saying here is, remember when I did this one right here? Go back to the board, I had the 1, 10, 2, 23, 30. When I plugged in a 1, I'm going to get a 10. I plug in a 2, I'm going to get a 20, plug in a 3. So in this one, this says if you use this equation right here and plug in a 2, what you going to get out? A 5. If you plug in a 5, you're going to get a 10. That's what that equation is going to do. You got it? Now in the homework, it ain't gonna want you to put how many digits is it after the decimal? 9. What is that? 9. Yeah, they look like 9 digits. In the homework, it's gonna tell you, I want 2 places, 3 places, or it might say tenths, hundreds, thousands, but it's gonna tell you to round it to so many decimal places. So let's go ahead and round it. I want 3 decimal places. So tell me what you want me to round that number to. The first number is gonna round to what? I've got y equals 1 point what? 3 places. I need 3 places. 5 what? 5, 7, 7. Excuse me. 5, 7, 7. Okay. X. All right. What do I put over here as my second number? Done. That's your answer. That's what you would be putting in my math lab. Is that in y equals mx plus b form? It better. It's linear. We're talking about linear functions now still. So if it wants a linear function, you need something like that and round it to however many decimal places it says. Okay? Questions? So can you, now when it comes to the homework, you're going to have to cut and paste data in here. You can type it hand by hand. My preference is that you cut and paste it. Why? Because after you start typing so many numbers, you're going to fat finger it and put the wrong number in. But I'm not saying you shouldn't. I'm just saying you got to have a separate screen. Like if you do a split screen like I have so you can see the data table and type it at the same time, that's perfect as well. If you can split your screen into 2 screens so you can see both what you're typing and what's in my math lab at the same time. Questions? What you thinking? This not so bad, is it? Question?
There was a question on the quiz,
Yes.
and I got it wrong.
About this?
It was not about linear regression, but it was about what we covered,
2.1.
What you round to?
no, it
What
was
was-
about, exact and approximate.
Okay. Now, so let me say this about that. In the homework, when you get to those where it's going to ask you if it's exact in a match or an approximate match or not at all. There's a couple of them where my math lab says it's exact. It ain't exact. Because the actual numbers that you see for your first differences, they're not the same. But it calls it exact because the numbers were kind of close, but it's not right. So I'm just giving you a heads up. It's going to mark a couple of them. I forgot what numbers they are. But they call them exact, and they're not exact. So just know that's coming.
Towards the end, the last, 3 questions.
Okay, so just take a look at that, but I'm saying that does happen, and I don't know why they got them like that, but it's not right. So you're gonna see that in the homework. All righty, but in reference to doing this, are you okay with being able to type your data in here? So you can either type it so you can see it in Desmos, but this tool just creates the equation for you. That's all it does. It doesn't plot the points, it just creates the equation. So now, can I go put this equation in Desmos so we can see it? So I can see it connect the dots? Sure I can. What do we have? Y equals, what we said the equation, y equals
1.5
1.57, whoops, that's not a point, 0.577x plus what?
1.89.
Okay, all righty. Did it connect my dots? Or did it get as close to the dots as possible? Yes, it did. It is on some of them you can see it's almost sliding off the dot, but that's called the best fit line for that data. So once you put your points, you can, if you want to go back and actually see the actual line, you can. If you want to see if it touches the data or not, you can. So let's get me all hooked up here. Alrighty. Okay, so we're good? This makes sense? Okay, alrighty. So let's go back to the PowerPoint and make sure, see what our next slide says it wants us to do. Alrighty, so we're good with that. Discrete and continuous, when you have data, if the data has a finite number of input values, it's considered discrete. Does this table have a finite number of x values? Look at the table. Does it have a finite number of x values? Finite means a set number, a constant number. It doesn't go. Does the x values go on forever? No, they're finite, meaning they are a set of values that don't just keep going on forever and ever and ever. Are there an infinite number of input values? Not in this case. So this is considered a discrete model. It has a set number of input values. What are your input values? 2, 5, 8, 9, 10, 12, 16. Is that a set number of input values? Then it's a discrete model. Okay, so let me go back to the slide. Now you have a situation also where you could have a continuous function, a function with an infinite number of inputs. Well, that ain't this one. That one doesn't have an infinite number of inputs. But can there be one that does? Well, let's get to it and see what happens. So here we're going to talk about the models themselves. In the next slide, I'll give you the examples associated with discrete and continuous. And also, we're going to talk about what's interpolation and extrapolation. Let me explain it when I get to the data so you'll be able to make more sense of it as we get to the data. All righty. Let's talk about it from this standpoint. If $1,000 is invested at 6% simple interest, the initial value and the future value, S, we're calling the future value S, at the end of each of 5 years are shown in the table below. Okay, all righty. Instead of X and Y, what letters of the alphabet are we using for the variables? T and S. So T is X and future value, which is S, is going to be your Y. You don't have to, I'm just trying to make sure you understand input, output. They're using different letters of the alphabet. If they use different letters, do you have to use different letters? Yes, you do. So you have an XY table. My table values for my input are 0, 1, 2, 3, 4, 5. My output values is how much money I have in the future. Well, how much money did I originally invest? $1,000. So at 0, which means I just took it to the bank and put it in the bank, I just got $1,000. After 1 year, how much money do I have? 1,060. After 2 years, 1,120. After 3 years, 4 years, 5 years, and so forth. All right, the question is, bullet number 1, can a linear function model this data exactly, approximately, or not at all? What we supposed to do to tell if it's, we got to do the first differences. Did you subtract 1,000 and 1,060?
Yes.
How much is that? 60. Well, what's the difference between 1,060 and 1,120? 60. And what about 1,120 and 1,180? 60. And then 1,180 and 1,240? 60. So you can see the first difference is always going to be 60. So is there an equation that models that data exactly?
Yes.
Yes, there is. And so now it says, if so, go find the equation that models that data. It says find a linear function, meaning you got to use S and T, that models that data. Where are you going to go put that data? Now, if you put it in Desmos, what's Desmos going to do? It's just going to plot the points. What does it want you to do? I want you to find the equation. So what you going to do with the data? Go put it in Zuru. xuru.org. Linear regression, go. You gonna type that in?
So we just put it in decimals, actually, just like the checking.
Let me know when you got the equation.
I think y equals 6x plus 1,000.
Say it again.
I got y equals 6x plus 1,000.
Okay. Did everybody get the same thing? Okay, so tell me what the equation is again. The linear function that models the data is what? 60x
Plus 1,000.
plus 1,000. All right, that's the equation that models the data. That's it. That's what you would type in Desmos, except if not Desmos, that's what you would type in My Math Lab, and it's gonna mark it wrong. Why? Because I didn't use what? I didn't use the variables. What variables am I supposed to be using? So if you type this in My Math Lab, it's gonna be wrong, even though I know it's technically it's right. But they want you to use what letters of the alphabet? S and T. So this has got to be S is equal to 60 times T plus 1,000. I'm just telling you because it's gonna happen. You be like, I know the answer, right? You got to put it in S with S and T, not X and Y. So whatever they use, you got to use. Now let's look at. Do you have questions about that? Yeah, you just type the data in and click calculate. All right, bullet number 3. Use the model. When you say model, what are we talking about? The what? The equation. Every time we say model, we're talking about the equation. It says, so use the model to find the future value of the investment at the end of the 7th year. What are we supposed to do? It says use the model to find how much money I'm going to have 7 years later. So what y'all want me to do? So where the T is, the 7 years.
Right.
So T equals 7. So I'm supposed to put a 7 in the place of that T and then do the math, right? Okay, so what should that come out to be? Y'all know, what should it come out to be? 7 years, how much money am I have? 1,000. Alrighty, so this is a 7. So T equals 7. I'm going to erase this and put a 7. So it's going to be 60 times 7 plus 1,000. And you said 60 times 7 is 420. Alright, plus 1,000. You said my final answer is I'm going to have $1,420 at the end of 7 years. Now, you okay with that answer? Could I do the same thing for 8 years? 10 years? 15 years? Exactly. I would just plug in the number of years. Now look at the question at the end of that word where it says 7th year. Is this an interpolation or an extrapolation associated with the data? Interpolation means, can I pick a year inside of 0 to 5? Or did I pick a year inside of 0 to 5? Look at my data table. What's my years from 0 to 5? Did I pick a year that's from 0 to 5? No. So if I pick a year that's outside the data table, it's called extrapolation. So the 7th year that we picked, the information for the 7th year is considered an extrapolation because it's the 7th year, and the 7th year ain't nowhere in that table at all, is it? No. So if it's outside, it's extrapolation. Now what if I say I want to know how much money I'm going to have at 2.5 years? Is that interpolation or extrapolation? It's inside the years from 0 to 5. So if it's inside, it's interpolation. If it's outside, it's extrapolation. You got it? Okay, so if I say I want to know how much money I'm going to have at 4.5 years, interpolation or extrapolation? Interpolation. Questions? You're good?
Okay, go ahead.
Questions?
So, that only refers to X's, right? So interpolation X, those words only refers to the X, right?
It's asking you first, the answer that you, so if I say for 2.5 years, the answer you're gonna get, let's say it's gonna be $1,150. That answer is gonna be considered interpolation because of the X value. So we are looking at the X value to see if it's between 0 and 5. That's how we first look at it. So you're right. We just originally look at the X value to see if it's between 0 and 5. If it's not between 0 and 5, it's outside its extrapolation. Now, question. That fourth bullet says, should this model be interpreted discretely or continuously? All right, so here's what discrete and continuous mean. Discrete means there's a finite means there's just an exact set of numbers for each year. Is there?
Yes.
From 0 to what?
5.
Is that a finite, or there's a set number of numbers for the years?
Yes.
Yes. So, are there an infinite number of years that we have on the screen up here? No. So, but from 0 to 5, we're just looking at those years. That's all. Yeah, you might want to look at a half a year, but in most cases, if you put money in the bank, are you gonna watch it? You're gonna go check on it at the first month. You're gonna go check and see how much money you got. The second month, you're gonna go check see how much money you got. You might, but in most cases, you just put it in the bank? Are you expecting it to grow that fast? No. So the point is, usually for a table like this, it's discrete because you're only going to be looking at it for a set number of years, an exact number of years. You got what I'm saying? An exact number of years. Whether I had made it 0 to 5, it could have been 0 to 8, but right now it's set for 0 to 5 years. That's a set number of years. That's considered a discrete model. Yes?
So we're only looking at the X values when we're looking at that?
Correct. Focus on what the X values are. Now, I will give you the continuous example with the continuous model with the next example. So are we good with this? You can tell this is discrete. It's got a set number of years for the X values. Here's the last one. The table below shows some sample incomes and the income tax due for each taxable income. Y'all understand what the words mean? Remember, anytime you start talking about a word problem, you got to make sure you understand what every word in the word problem means. Do we know what taxes are? Do we know what your taxable income is? For those of us who work. You know that time is coming up soon where you got to actually do your whole, what you got on your W-2 and fill in all the information to go and do your 1040, right? So do you understand the words associated with that word problem? Okay, so they gave us a table. It says the taxable income and the income tax that you owe the IRS if you make how much money? If you make $30,000, how much you owe the IRS? If you make $30,050, how much you owe the IRS? Okay, so can you see that they just picked some numbers? They just picked a range of salaries from $30,000 to $30,300. We just picked that range of salaries and just said, hey, we're just guesstimating the taxable income, your income tax due to IRS might be those numbers that you see on the screen. So let me ask you a question. Let's start with bullet number 1. Can a linear function model this data exactly? Well, what do I go do? Subtract these two numbers, what you get? 750. When you subtract these two numbers, what you get? Should be 750. You get it? And these two numbers, 750. And these two, 750. So if you go all the way to the end, the differences between each one of those Y values is $7.50. So is there an equation that'll model that data exactly? Yes, there is. Guess what? They want us to go type this information in and see if you can tell me what the equation is for that data. Don't put it in Desmos, put it in Zoro. Can I put any of the commas and the dollar signs and any of that in it? No. So all you're supposed to type is 30,000, whoops, no commas. And then the comma goes here, and what's my first number? 3665, done. If it has 50 cent, you gotta put the 0.50 in there for 50 cent. You got it?
Say that again, if it has 50 cents, you have to do what?
You do have to put the, if it has 0.50 in there, you do have to type it as 0.50.
And do you check that little box at the end of, there was a box at zero, at that
In Zuru?
zero, yes.
No, you just, all you're doing is hitting calculate. So I want you to type it in first. So let me click on it just quickly to see. Make sure I got. No, it automatically allows commas. If you only want commas, let's see, as a decimal separator, we're not gonna do any of that, so don't check that box. All right, let me go back to where I was. All right, there we go. Let me know when you're done typing. Don't put any commas, but you do have to keep the decimals. Don't put any dollar signs. Don't put any dollar signs. Anytime you put data in here, the only thing you should have is a comma, and if it has a decimal, put the decimal. But no dollar signs and no extra commas. If you put the commas in the wrong place, you're gonna get the wrong equation. So the second one should look like this. Let me know when you finish. You finished typing? If you finished typing, what equation did you get?
Y equals 0.15x minus 835.
Minus what?
835.
I want to make sure everybody got the similar equation. Let me know if you're done.
So when we put this in my math lab, we're using X and T.
Whatever letters they use. So if they use T equals, then we got to put a T right here. So if it says T, I should have a T right there. Whatever letters they use, you use. Why do they use T? Taxable income. Alrighty. Everybody got this same equation? Did you get this equation? Nod your head if you got this equation. If you didn't get it, are you concerned or are you like you okay? Questions? Y'all, I can't read y'all mind. Y'all know that, right? I wish I could. Then that would be easier. But I can't tell. If you didn't get it, I want to know, are you okay if you didn't get it all typed in? Okay, y'all not saying anything.
Yes.
Yes, y'all, okay, so that means I can go on?
Yes.
Okay, all right. So the equation we got, let's go to the bullet. We got the equation. We got the function that models the data. It says verify that the model fits the data by evaluating the function when x is equal to 30,100. What does that mean? It wants you to prove to me that this is the right equation. So what it wants you to plug in for x? 30,100. So plug in 30,100. This in your calculator. Put 0.15 times 30,000, oh, you don't have to put a comma. Put 30,100 minus 835. What answer should I get? If you ain't get that answer, guess what? Our equation not right. We should get this answer if we plug in 30,100 into the equation that Zuru created. If you get 3,680, your equation is right. It's just wanting us to check and make sure our equation is right. So when you put it in the calculator, did you get 3,680? Yes, so that's, our equation is right. And it's asking you to do the same thing with 30,300, but we don't have to do it. We know it's gonna come out, right? So those answers match what's in the table. So now here's the last bullet. If the model, meaning the equation, can be interpreted continuously, use it to find the taxable income for 30,125. So let me ask you a question. Where would 30,125 fit in the table?
30,130,000.
Okay, so it's gonna fit in between here? Okay, is that interpolation or extrapolation?
No,
Okay,
it's
Okay,
It's within the table.
is it in between 30,000 and 30,300?
Yes.
It is, so it's which one? Interpolation. Okay? If it's gotta be it's gotta be somewhere in between 30,000 and 30,300. Now what if I ask you to do $31,000? Is that interpolation or extrapolation? Because it's after the table is already finished, so 31,000 way over here somewhere. Okay, we're good? But now what about continuous and discrete? This is a continuous function that we just created. Why? How many salaries are in between each one of these numbers? How many salaries between 30,000 and 30,050? We all make different salaries, don't we? So I could be $30,001, $30,002, $30,002.50, $30,003, $30,004, $30,004.45, $30,005. How many salaries are in between those two numbers? A lot. So because you got a whole bunch of salaries between 30,000 and 30,300, this is considered a continuous function because you got so many salaries that you're not going to be able to count all of them. You understand what we mean? It might be 300, but I'm just saying there's so many that you're not going to want to count all of them. This is considered continuous because there's so many salaries in between those numbers. You understand what I'm saying? That's why we have a tax table, right? When you go look at the tax table, don't they have it divided up into range of salaries? So they're just saying there's a gob of numbers between 30,000 and any of those salaries that you see up there on the screen that is considered a continuous model. Okay? And we're looking at just the input now, just the X values for determining whether it's continuous or discrete. Okay, let me go to one screen back. I said that one was discrete. So here's the point. Would you want to go check how much money you got at 1.3459 years? No. So it wouldn't even make sense to do it like that. So that's why we're calling this discrete. Usually I could say you might want to check it at 1.5 years, but you ain't gonna check it at 1.3459 year or 2.6856. You see what I'm saying? So you gotta do some logic with it too that comes with this. This is still discrete. We're only looking at numbers between 0 and 5. So again, just back to the slide, make sure that's a continuous model now. So questions? Homework. I need for you to pull it up because I need to show you how to cut and paste your data into Zuru. So I need you to pull up homework for 2.2 really quickly, please. Here is the 2.2 homework. Well, it's gonna make me log back in. Hold on. If you'll pull up 2.2, I just want to show you how to cut and paste your data. All righty. And I need to give you your tests back, so I'm going to give those back to you in just a second. All righty. No, I picked the wrong one. Yeah. All right, 3.2.2. All right, look at, let me see what number 11. Pull up number 11 and see what number 11 looks like. Are you on number 11? All right, for number 11, you have some data. Do you see the table? Look at this little box. Let me see if you can see this little box. See this little set of boxes overlapping each other up here on the top right of your table? If you click on it, left click, it opens up a copy to clipboard box. Let me make this smaller so it'll open. See it says copy to clipboard? Click on, left click on copy to clipboard. It's gonna open up a window that lets you see all the data. It should be in blue. All of it's in blue. Right click. Right click in the blue. Hit copy. Now go to Zuru. So go find your Zuru page. Alrighty, let me open this window up so I can see it all together. Delete the data you already have in now, so just scroll over it and delete all of it. Got it? Right click and hit paste. Right click. Yes. Now, there's one problem. This data is not in the order that you want it, so we gotta fix it. Could you just type this in? Yeah, or you can fix it. First of all, we can't have any of these where it says these up here up top. You can't have any of that. And then you can't put 2010, 2015, 2020. It never wants to see the actual year. So go back and look at your homework assignment. Let me go pull it back up again so you can see what it says. Where is it? Here. Let's read and see what it says really quickly here. All righty. It says find the linear model that fits the data. Notice what it says right here. X equals 0 for the year 2000. So can I put in the 2010, 2015, 2025, 30 in my data table? Can I put it in Zuru? No. You got to go change this to, if X equals 0 is 2000, what's this one going to be? 10. Subtract 2000 and then 2010, that's 10 years. If I subtract 2015 and 2000, that's 15. So this is going to be 10, 15, 20, 25, 30, 35, 40, 45, 50. That's what you're going to change those numbers to in Zuru. You got it? So we're going to go back to Zuru and fix it. Alrighty, so here, I'm going to fix this. So this is going to be, I'm going to backspace that out. I'm going to backspace that out. Alrighty, you see what we just did? I'm also going to kind of hit my enter key because I need these to be in a line. And I'm actually rearranging my table here because I need all these to be in a vertical line. Trying to make sure I type this in here right. All right. Alrighty, so let's see if I got this right. All right, so that's maybe not in the right place. You got to reorganize. So the data has to flow like a straight 2XY table. So I've got this mixed up, so I got to go back and fix it. I'm gonna cut and paste it in here again so I can fix it right. All right, I just deleted it. Alrighty, now let me see which way I want to do that. So if I put this one, I'm trying to get it to be in a straight line so that underneath here.
Why don't you just copy and paste 45, put under there, and start at 40, put under there.
You see how it's copying? It won't let you like copy pieces like you're trying to copy it. So I'm gonna have to kind of makeshift do it myself. Alrighty, so I'm gonna put, so 25 will go here. You see this part right here? That's gonna go there. Let me see if I actually do it this way, see if it'll let me do, hold on. That's putting the 50 there, but then it's not gonna put it in the right order. All right, let me put another space there. Guys, I'm just playing with this cutting and pasting and putting it, but you can see how you gotta kind of play with it to get things to go where you want it. Do you guys see? Mm-hmm. Okay, so then that was that. I'm copying that, cut that piece away, and I'm gonna put it over here. I'm just putting everything in the order that I want it in. All right, paste this in here, paste. Alrighty. Alrighty, so now I want this number to go in here. So I'm gonna put a space, and I'm gonna paste this one here. I'm gonna put a space. Hopefully you doing yours while I'm doing mine. I'm just dragging this or cutting and pasting. I'm just dragging it right now where I want it. Alrighty, and then we got 20. Bless you. Alright, and delete the words. So delete your words out. I don't want any of the words. Delete the words. Alright. Is it okay to have a space or a comma? Yes. Like I got a tab space in here. I can leave it with these spaces between them. I can't leave 2010. It's just got to be 10. So backspace. So I'm going to backspace all of this out. And if you figured out how to do it better than me, that's a wonderful thing. Whoops. And now I have my data like I like it. That's how your data should be when you get done with it. Or you can hand type it. I'm not opposed to you hand typing it, especially if it's this small. Sometimes the data set is going to be bigger than this, and it'll be all vertical so that you won't have to kind of realign it like I had to do. So now I'm just going to click what? Click calculate, and there is the equation that it created after the word results. Now, if it wants 3 decimal places, you have one thing to do. I need to show you this quick part, and then that's it for this. All right. It says y equals 4.973333. Do you see the 10 to the negative 1 power? You got to do something with that before you can give me the final answer. So anytime you have this 10 to the negative anything power, you got to move your decimal however many places to the left. So it's a negative 1. How many places to the left? 1. If it was a 2, move it 2. If it's a 3, move it 3. So what's my answer now? So this is going to be 0.4. How many places do I want? 3. So 0.497x plus what do I want? 11.191. Done. That's your answer. That's the equation for that data. That's the equation that models the data that we just typed into Zuru. If you put in the answer is going to be 4.973, it's going to mark it wrong because you didn't move the decimal over 1 place to the left before you start rounding. All right, while you guys are finishing that up, I'm going to call your name, come get your test. Overall, the tests were mostly A's and B's. I mean, there were several hundreds. I mean, the majority of the class made an A or B. Y'all should pat yourself. Y'all did good. Y'all did good. All righty. Quandra. Nathaniel. Helen. Rhonda. Dexter. I'm done if you're done. So once you get your test, you're dismissed unless you have questions about the test. Dexter, Monique, Beverly. Sign in sheet. If you didn't sign in, make sure you sign in. Will, Monique Patrick, Kyla. Was that yours? Kyla. Okay. I thought that was yours.
I didn't get the.
Oh, sign in on the sign-in sheet. Zachary. Janicia. Which one of y'all said right here? I'm looking at Zach. If you have questions, please ask me. Randy. Achi. Randy. Victoria. Samaj. Achi. Naomi. Janelle. Nasha. Nasha. Janelle. Naomi. Naomi. Yeah. Janelle? Tanya Williams? Okay. Monet Richards? Sheena? Emily? Emily? Which one?
Monet.
Monet. Sheena? Maya? Okay. Lisa? All right, hold on. Whose name did I call it then? All right, I've got Kyla. Which one? Lisa. All right, Lisa, hold on. Lisa? All righty. So I've got Maya. Is it last name Williams? Tania? Is it Tanya or Tania? Okay, so Tania, Maya, Kyla. Hold on. Oh, wait, I'm missing some. Hold on. I got a whole set. Okay, Jason. Okay, Jay. Kaylon.
Thank you.
Shaquaria. Okay. Which one? Jason. All right, Jason, hold on. Here you go. Jay. Okay. All righty. Who else am I missing? Okay, so I've got Kyla, Maya, and Tanya. Did I miss anybody else that I didn't give your test back? Okay, I need your stuff. What was your last name again? Okay. So you got that. All right, let me put that there. Tell me what you said, because I forgot.
Transportation.
Okay, gotcha. So what's your next available, when are you gonna be here?
Outside of us already scheduled, or?
Are you in the 5:30 class?
Yeah.
Okay, what
Well,
about,
the next week.
yeah, are you, what's today? Today is,
The
so you wanna do Thursday
can.
at the 5:30?
Yeah.
All right, let's do it then. Okay.
Thank you.
Yes, ma'am. What?
Is this not one because it's not?
It wasn't a
line?
yes, it had to be a straight line. That was it. Because I saw several people put it didn't pass the vertical, and actually, when you draw a line, it does pass, but it doesn't look like the shape of a line. That was it.
I'm sorry, thank you.
But no, several people put it didn't it passed the vertical line test. So I was like, okay.
So it's supposed to be this week the midterm grade?
No,
The homework?
it's gonna go all of it. The homework, the quizzes, all of that's going. I've already put them in there. So when you go back and look at my math lab right now, you'll see what the grade is, overall grade right now with the homework. No zeros, just what you've done, and that test got put in. So we'll probably have another test before midterms go in, before the actual midterm grades go in.
Okay.
Okay? What questions do you have?
I don't even know.
Let me see what I wrote on your paper, because as y'all can see, I wrote stuff on your papers if there was something going on.
I thought I did way better.
Okay, so let me see what you did. All right.
See, okay, I know what fat I didn't get.
Okay, this one was, did it look like a vertical line? Did it look like a straight line?
I probably just forgot that. I probably rushed you down.
Okay, this one was on the study guide. I said, don't plug in zero, set it equal to
I
zero.
think I did.
So, and I was like, do you know how many people still plugged in a zero after I said, do not plug in a zero? Okay, so let me see what else you got on here.
No.
Alrighty, so I was looking for, okay, so like what happened with this one? This was, this one. Okay, so you had this, set this equal to 4320 and work that one out. This one, you had to do the y minus y1 and the m. I was looking for all of that. I didn't see that. This you had to set it equal to 0. Where is that one at? Yeah, this one,
It was just wrong.
you like, I'm like, where do I go from here?
Okay.
So then this one, you had to do the slope. 2,700 minus 300, and then 400 minus 100.
Yeah, see, that one I forgot how to do. So I knew I was going to get that one wrong.
Okay, but all of this
Yeah.
was on the study guide.
Yeah. Jesus. Okay.
Okay, so again,
Thank you, though.
yes, ma'am.
You know, I wrote the wrong thing here, but I put the right answer.
Okay, wait. The answer is C.
Oh,
Oh, okay.
You see what I'm saying? The answer itself is C. So I put that because the actual C-intercept is the 137. Remember I said the question, is it written in y equals mx plus b?
Okay.
Is it? Look at it. Is it written in y equals mx plus b? Look at it again. So that's, what is it? C of x is equal to 137 plus 0.025x. Alrighty. Now, remember I said it could be written like this, or it could be written like this.
Right.
Did they switch it around and write it like that? Look at the equation. Did they switch it around and write it like this? So remember, this is your y-intercept all the time.
Okay.
So for them, that was a C-intercept. So the cost is right, but this number is,
But the.
it had to be
but-
C.
Okay.
You see what I'm saying?
Yes. Okay.
Okay?
I was also gonna ask you, I'm sorry, penalty for doing homework late, is that also?
The penalty is just, if it's late, you open it and go at the end of the semester, you can go back and change it or make it better for the homework. The quizzes, if you have more quizzes left, you can still go do it. If you have more options, so if you have 3 chances to do the quiz, if you use up all 3 now, then you can't go back and do the quiz.
Well, I had done homework yesterday, and I was supposed to be like a 10, and it says turn in past days, and I was, but I have 100 in there,
Yeah.
so.
So did it change it? Did it change the grade or anything? So it's still a 100?
Yes.
Okay,
I just wanted to make sure it was, if it wasn't gonna be 100, how much would be off my face for not turning it on time?
no, it usually, once it's already past the due date, it shouldn't affect it negatively if it's late. It's just that, you shouldn't be able to go back into it and fix it after the due date. You know what I'm saying?
Right.
So that's what I'm saying. It's not supposed to let you go back in and fix it until I reopen it. If I reopen it, you can go back. But if I don't reopen it right now, then it's not supposed to let you go back and fix it. You know what I'm saying? Did it let you go back and do anything?
Well, it just.
I need to look at yours. Let me look at yours and see. Yes, ma'am. Yes, ma'am. That was good, though.
Oh, honey, you don't know how happy.
Oh, okay. I thought you felt like, okay, that was good.
No, really.
That was good.
Oh, you just don't know. I need to go home,
Okay, gotcha.
but I had emailed you because 2 points, well, I understand it now, but I wasn't getting it.
Gotcha.
all.
No, that's
I
fine.
did
Hopefully
part of
that
the
gave you
homework.
some
Yes, I did
ideas of
part
what you gotta
it,
do.
but
Okay.
I couldn't do it all because when I did look at the example, they were giving me something that.
I got you.
But I-
But now, was that test fair? Was it,
Oh.
we were rushing, so I always ask, was that test a fair test? Did it cover what we covered?
Because you covered, you put on your test what we discussed. You didn't have any.
I ain't gonna throw you no curveballs.
Yeah, see, that's where you know.
I understand. No, I want you to be able to utilize the study guides. That's why I create the study guides. Thank you.
Some of it's probably wrong, so
I think I put you guys again.
Oh, look, do I look like I need some candy?
I had bought everybody a Valentine's.
Oh,
But I left it in the trunk of my car.
it's all good.
So have a good day.
You too. Okay, so I still got 3 tests left. All right, so that's good. Golly, so she just gave me this. All righty.
go down to where I'm doing my first order. And that's where I got my Zeus stuff, click on that. And it puts mine, so when I'm gonna change their own little decimals, but then they want to go so to go down here, okay,
If you were gonna look at that, you would look at it later, right?
I can pull it up now. I'm just, yeah, I just wanted to see if there was anything that actually changed that you needed to see. So I can still pull it up now. Let me put these other tests back. Okay, she just gave me that. Let me put this back. And let me take it off of big screen.
hit the snap left.
All right.
See, I have a lot of, all.
And I don't think I realized that
Okay,
we
you have got to,
one of
you have
them,
got to do
I
that.
had
You have
gone back after
But
I
you know
finished
what?
it to like double check a problem, and I didn't X it out, so it says that I turned that one in.
Oh.
too.
It'll give you all your windows. It'll give you all your
Alrighty, so grade book.
If you got 4 windows open, or 3, like we have to do sometimes, but I wanna see, like she says, if I am side by side like this, I can type it in, cause you can see it. That's it.
Okay, so come around here so you can see. So here's what I have for what you've done so far. So of course it shows the overall grade, which is good, and it shows the homework that's completed and how much time you spent on each one of them. So you can see 2.1, you've got 100. There's your quiz 1, quiz 2, quiz 3. So was there one particular homework you were thinking didn't do what you thought it did? Because right now this is still at 100, that's 100, that's 100. That one's at 93, and that one's 100. So the only one that's not 100 is at 1.4. Is that what you saw it as last?
I
You
don't really
remember?
know, to be
Okay.
honest.
Okay, but other than that, everything looks like it should.
Okay, well, so, but at the end of the semester, like you said, I can go back and do the homework as well.
So for example, like for the quiz, like for this one, did you do all 3 quizzes?
I didn't, no.
Okay, so then at the end of the semester, you can go back, or that week before everything closes, you can go back and redo this one if you want to increase that grade.
And I can do that with the homework too, because I don't,
I mean, like say with this one, if you say, well, where is it? This one right here. You can go back and do that one, you can go back and do that homework, instead of making it 93, you can make it 100.
I remember why. Okay, yeah. There was one I just couldn't figure out. So now, okay, that's perfect. Thank
Okay.
you. A lot.
But it doesn't matter.
Have a nice day.
You too.
If you click on it, that's fine. Now, that's right. So now you go to
Did you ladies have questions for me? I'm gonna walk next door.
Okay, and we'll be there.
Okay.
We're gonna set it up my computer so that way I can.
No, that's
copy and
fine,
paste.
take your time.
Okay, thank you.
I can see, and that's how you go to your, you don't have any favorites here. Let me set you up with your favorites. First thing you want to do is, you have played things out with your favorites.
So yeah, this is my favorite. That's the only thing I do pass.
Okay. So, let's go for. That is so weird. Why don't you go back to that? When you get your car right here. Oh, she must be working with something. Okay.
So that's 15.
Okay. Click on Chrome.
Click on Chrome.
I don't understand why I wouldn't click on Chrome. Home is Chrome, homepage. So that's.
Okay.
Now. Let's.
All right, 16.
Come on, take me there. It's so fun. Who's at the computer?
When all I did was set it up for the print and stuff, that's it. Well, just the things that's on.
So you want,
Zoom,
let's see,
that's
please state this, you need, get on this other website. Oh, here it is right here. I like that. There's your demo. There's your regression tools. And you have them all as favorites.
okay, you just did that.
No, they were there all the time. I'm looking at them. So, I want you to put your, click and state. What I want.
Okay, now we're gonna make. That was
Okay, let's see. All right, I'll be right back, you guys. Okay, guys, what questions do you have?
I have a question about Zero.
Mm-hmm.
Where are you going to put in that information, like which tab?
Linear regression.
Okay, so it's under the regression tool?
Mm-hmm.
Okay. Okay. I just didn't know how to get there.
Okay. Any test questions that you guys have in reference to the test that you got back?
So I went ahead and checked those, and because it's.
Alrighty, so that's turned on. Are y'all working on 2.1 or 2.2? 2.2, okay. Guys, I need to point out something about number 7. If you see number 7 on the screen, when you get to number 7, remember we talked about doing first differences? Can I rewrite this as a XY table? Sure, right? So if I rewrite it as an XY table, there's one small problem. So if I rewrite it horizontally as an XY table, so that's gonna be 1, 4, 5, 6, 7, 8, and 10, 10. Now I could do the first differences, but you can't. And the reason why, and I didn't say this in the early class, all of these numbers as X values have to be one space apart or the same, let me rephrase that, they have to be the same distance apart. So this would have to be 1, 2, 3, 4. You see what I'm saying? Or it have to be 2, 4, 6, 8, or it have to be 3, 6, 9, 12. They gotta be the same distance apart in order for you to do the differences between these numbers. You understand what I just said? These numbers up top here gotta be the same distance apart. So notice the distance between 1 and 5 is 4. The distance between 5 and 7 is 2. And the distance between 7 and 10 is 3. They all gotta be the same distance apart before you can do the first difference.
So it would be that they're not.
So it says that choose the correct answer. The difference between the inputs is not the same. This word means not constant, means not the same.
Okay. So the difference has to be the same in all the input values.
Right, and these are the input values.
And then,
All your x values have to be the same distance apart.
and that's for first differences.
In order to do the first difference, they have to be the same distance. So you can't do this at all unless these numbers are the same distance apart.
Okay.
Okay, so y'all, this wasn't a bad, I mean, the homework assignment actually was pretty simple. You know, you got the last like 3 or 4 where you gotta cut and paste the data, but other than the first like 7, they're like easy. Mm-hmm.
So like on this one, when you did an example in the other class on the years, you did like just use 10, 20, 30, 40 years.
Mhm.
How did you do that for 2000?
And this one, since it's starting at, so it tells you here that we're gonna count from 2000. Does it say anything else about X being the number of years? Okay, so X is the number of years after 2000. How many years is 2000 after 2000? So you just subtract these two numbers. So 2000 is 0.
So then we're just starting with 10.
You gotta start with 0. See, because what's the difference between 2000 and 2000? So that would be 0, 10, 20, 30, 40, 50, 0, 60, 70, 80, 90. That's how you do it for that one.
And you always do that for the years, you never break them out.
You're never gonna write the years out.
Ever.
Mm-mm.
That's what I'm saying.
This is question number 3.
Mm-hmm.
Can a square peg the part can it be exact or approximate?
So what you going to do?
I'm not sure.
Okay, so we talked about you have to do the first differences to be able to determine if it can or cannot. So if the first differences are all the same or all constant, then it can be exact.
Okay.
If they're kind of close, then it's approximate. And what's the difference between 2 and 5?
They're all 2. Whoa. Am I looking at the outputs?
You're looking at outputs, never, don't look at the inputs. When you do first differences, you only do the first differences on the output.
Oh, okay.
Okay?
So that's 3.
Okay, so what's the answer?
It's exact.
Yeah.
So,
So you just put exact.
okay.
So that means that there is an equation that matches that data exactly.
Okay. So if the first differences are
The same.
the same.
And then, like the question we had on the board previously, all of these X values had to be the same distance apart before you can even do the first differences.
Right.
So, but that was already the case, so you were good.
Okay.
Okay. Okay, so create a linear model, which means it wants you to create an equation. So you type the data in? Let me see your data. Okay, that's your equation. Let me see your data again. Okay, create me an XY table on your paper with that data. I wanna see a vertical XY table. Okay, now let's go back and look at yours, your data in Zuru. Okay, let me look at it. Okay, and then let me look and make sure, I'm gonna touch yours. Does it say linear at the top? Scroll up to the top of the screen and just make sure it says linear. Okay, it does. So that's right. So now, the equation, let's go back to my math lab and see what it asks us to do. Write a linear model, type the answer in slope-intercept form, use integers and decimals, and then it says round to 3 decimal places, so that's what you did, right? Okay, let's go look at it again. All right, so that's gonna round to 1.105 x, and that's gonna round to 3.158. That's gonna turn into an 8. You see why though? See that after the 7, that's an 8, and that 8 is bigger than 5, so it's gonna cause that 7 to turn into an 8.
Okay.
So that's the difference.
So the first one I had, so it's gonna change. So it'll look like this. Oh, I was putting in a plus sign.
Okay, now that's right. So it's just a rounding, so just making sure you round your numbers appropriately. So now
Okay.
type that in and see what you got.
And I'm using a different sign too.
Okay? So you don't need the Y, just, yeah.
Thank you.
Mm-hmm.
Okay, I have another question, just similar to the one I think I heard you talking about.
Mm-hmm.
Linear regression,
Mm-hmm.
what is,
It's just asking you for a linear equation that models the data.
okay.
So when you hear the word linear regression, they want you to use Zuru to create an equation. So it means create an equation, a linear equation.
So that's when we go to this
Copy
copy
it.
and copy report.
Mm-hmm. Right click in the blue,
Okay.
copy, and go to Zuru,
Mhm.
paste, right click. Okay, get rid of the X and the Y. Now hit calculate. There's your equation.
Here,
Mhm.
okay,
Everywhere, just look at where it says results. That's it, don't look at anything else.
okay,
And that's it.
okay.
On this last one, was I supposed to just put in 100?
Yeah, so, yeah, cause you,
Tell me what I'm doing wrong.
okay, so let me see, yeah, so you did do 0 to 2, okay, you did cut and paste it, okay?
Right.
And you got your commas in the right place. Okay, so can I see the whole all the way to the top? You have 0 at the top? Okay. Okay, can I see the bottom? And so when you rounded it to 100, that's what makes it 3. So you have y equals 2. Oh, okay. That is it, yeah, I thought you were cut and paste it, right?
No, I didn't.
You typed it, ooh, okay, so then you do have to look at it exactly. All right. So there you go. So yeah, just making sure, you know, that's the only thing with typing it.
I'm sorry.
No, it's all good to type it, it's just that when you do type it, you gotta literally check each number with each number, just to make sure. Cause it'll be something just that simple. but it makes sense though, right?
Yes, ma'am.
Good job.
Oh, no,
What happened?
my computer died.
Your power cord? I'm just checking.
Finish my home. Thank you.
What number did you get to, Quandra?
I was on, I think, number 8.
Okay, so you almost done.
Yeah. Oh, I did have a question, cause on that test.
On the test, yes.
Like, on the parts that I knew, I worked it out, and then the ones, oh my, it is the word. I didn't even answer that, I didn't realize I didn't answer that. Where I got one, I just mixed the negative, negative.
Mm-hmm, mm-hmm.
This one, I had a hard time with too. And this one, I thought about this one.
Cause you know, when it asks you for the marginal cost, it just wants the slope.
Right.
So you had to write your 2 points first.
Mm-hmm.
So your first point would have been 100, 300, and your second point would have been 400, 2700. And then all you had to do was write your slope.
Wow.
So, this one, you know, that one I think was right off, that one came right off the study guide.
Mm-hmm.
That one's directly from this, I mean, literally. And, yep, you got that one, you got that one.
This one, I got, look, I knew, is it D?
Mm-hmm.
I was debating on if it was that one.
Okay, so again, that one was like right from the study guide.
Mhm.
So again, when you set it up, all you had to do was replace this S of X with the 4320 and solve and get X by itself.
My head took this test.
Let me see.
Cause I did it like on the.
Yeah, this is right. That's right.
And this one, I got my
Right, you were like, what to do.
Yeah,
So
I remember this,
There
when
was
stage,
top tip,
and
high
type,
three,
yeah.
right. Mhm.
But I forgot how to do, you know.
Mm-hmm. So you had to do, remember you had to rewrite this with Y by itself,
Mhm.
so you know what the slope is, and then you had to do Y minus Y1 equals M times X.
Goodness gracious.
Hey, like,
It was hard. It's still not set up right.
it's not,
But
okay.
it's better. It's better.
Well, that's good.
Yeah, at least I can.
I don't write mine, I
She can get
put
multiple
like
windows,
on
so.
the side, did you?
Sign in sheet.
Oh, here we get it first. Yeah, but that's how it should be
Right.
written.
Oh.
Remember I said, do not plug in a zero, and when I tell you, do you know how many tests I graded and people plugged in a zero? When I literally said, do not plug in a zero, and y'all plugged in zero anyway, and I was like, what in the world?
Yeah.
Hold on.
Yeah.
I was like, what in the world? I'm like, I took it right there, you know, for that one, because that one was so easy. I ain't had no mercy for y'all on that one. That 6x plus 12 equals 0. I'm like,
It's always the simple stuff I can.
yeah, I was like, what in the world?
Like, for one of the questions, I was only supposed to find the slope.
Yes.
Yeah.
But I did that, and then I was down there, I'm doing all of the Y
You
I
were,
got that one
minus
right.
Y1.
Said number 11.
And I'm like, wait a minute, I don't
Yeah.
need to do that.
So-
I had worked out almost the whole problem.
What you
Yeah.
wanna do?
you gonna sign?
I'm gonna go to the restroom first.
You want me to set it up? You wanna try to
Yeah, 'cause
figure
I'm
it
gonna
out?
come back over here
Okay.
and see what.
But I got number 9 right. But I just put it in, I guess not how you wanted it.
Well, if you plug in a 0, that's totally not right.
Okay.
Because it said find the 0. It didn't say plug, you know what I'm saying? It said find the 0. So yeah, if you didn't, you had to do it the way I wrote it. That's why I wrote it like that.
Oh,
I got another question.
But I did get it right. Thank God.
Okay, I got this from, I got my page, 3 decimal points.
2 decimal places.
Yeah. Which one?
So to the right side of the decimal, you need 3 decimal places, so you're gonna have to round.
Okay.
So when you start rounding, you look at, since they want 3 decimal places, you gotta look at the 4th one.
Okay.
Is that 5 or bigger?
Yes.
So that means this number gets increased by 1.
Okay.
If it's not 5 or bigger, that number stays the same.
Okay.
That's the rule for rounding. If the 4th number is 5 or bigger than 5, increase this one by 1. If it's not, this number stays the same.
Okay.
So that's gonna be 1.829.
Okay, because I typed it in, just moved the decimal place, and I'm like, okay.
But you gotta move it and round if necessary. So for this one, it's 1.514, and it stays a 4 because
Okay,
that's,
so that's fine.
there you go.
And somebody emailed the girl I was sent to next to, she emailed me the study guide. Do you still want me to send your email?
No, we're good. You got everything done.
Yeah.
Yeah, I got everything. Oh, I didn't even stop it. I'm still talking.